Hi, my name is Gregor. I am in product management at Extreme Networks. I wear multiple hats, so for this one, I have another one, right? And I'll do the PLM stuff. However, I also had another hat. Man, now it's 8 years ago. I was one of you. So I promise you, this is my only slide. Yeah. So let's go in. So what I wanted to show you is what does the user get from all of the machine learning, all of the AI, all of the data aggregation, all of the scalability, all of the everything. So as an example, we have a demo network that we're running on a part of our corporate network, and this is something that we'll just exploit. Now, I'm super, super passionate about the product. That's why we have our own guys there equipped with all of the things that they can throw at me if I get over the time. So I'll focus in just something that we've never had 8 months ago. So all of the cloud, the backend, the architecture, whatever, and the end of the day needs to be applied and presented to what the user would consume. So I'll stick to that one. This is not a presentation of ExtremeCloud IQ as such. So one of the things that we would like to do is focus on what we call a 360 paradigm. Now, the 360 paradigm is a combination of what's happening with the client, like a client device or a user, what's happening with the devices serving those users, but the holy grail is really what's happening with my network. And machine learning and AI is being applied all over the place. Pretty much every single vendor can state a claim that they use it, because it's true. But it's really the question is, what problems are we solving? So our mission is to solve the problem, and this is what we're doing today. And we're solving the question, can I drink my coffee in peace, or do I have to panic? Right? And this is the problem. And it's just because we have this compute, we can look at the overall network, segment that information in different zones, and see, I'm green, I'm good. Let me sip that coffee. I can go into the details, but I'm fine. And just to explain what is happening is all of the information connected from a client, collected through a managed device, pushed into the cloud, is then segmented in a couple of different perspectives, devices, clients, Wi-Fi, network. Also to answer the second basic question. When somebody comes in and you say, hey, your Wi-Fi sucks, you can say, yeah, now your internet is down. Right? So simple answers to the questions, but the answers are contained on the network size, not on one faulty client. So, but we do have information about the clients. So let me start there, because this is where it all begins. As a part of every single client, we're collecting the data. On the left-hand side, we can see if the device is attached. This is my information now. On the right-hand side, this is the information over time. One thing to realize, we're not doing the calculation, we're not doing the aggregations. This is pulling in the raw data for the duration of 30 days, which is what we're offering right now. So everything that you see is pulled back in. So I will not go here, because I can spend a lifetime here. But one of the things that we have discovered over this is now 11th iteration in 8 months of the Client 360, is when you have such an amount of data, you end up also with anomalies. So one of the things that we're doing in the back end, we're doing anomaly detection and not presenting certain data. The first thing that hit us, as an example, was authentication issues. Right? We see authentication failed, whatever. And instead of doing this, we have discovered there are certain areas, and it's not a brain surgery, like exits, enters. when you enter the building or exit the building, and if you have an application running out, you will eventually fail. So there's a bunch of things that we're not aggregating using the anomaly detection, and then we're presenting the information in this way. The second thing that we're doing is, as that client is roaming, attaching, associating to different networks, there's all kinds of different mechanisms that we're doing to understand if the association, the session was successful, was it quality, and at the end of the day, was it good, and how did it compare to my network across multiple aspects. And if there's something really happening, we will cover it and compile it in the client events. And then you'll see, yes, authentication failure, yes, wrong password, yes, all of that. Nice little things. But once we get to a certain place, we go to a higher level. So this would be a device information. So if you think about Client 360 as a one-to-one relationship, this is one-to-many. So one device collecting many information. So in the so this was 1 hour selection in a day. Is this 1 hour? No, that's 1 day. We have served a bunch of clients, 167 on this view. I will not dwell on this at all, because this is what other vendors can do too. Let me bring it up a notch. Let me see the network information about certain parameters. One of them is and I'll do this particular session, and I'll do my third hat, which is my bread and butter, my love. I'm still a WLAN expert. Something that we have all done as WLAN experts for the last 20 years. Sniffing the client's capabilities, figuring out what the client can do so you can see if it's doing well on your network. It's pretty straightforward. Pretty much everybody can do it right now. Well, we can do it, and we are doing it for every single client across the entire population. So we have 6 million devices connecting every day. We're capturing 4 different for all of the 6 clients, and we can end up what their capability is. And
so one thing I would like to say is, if you notice, this is not how the client is using the network. This is what the client is capable of, because obviously sometimes your client is capable of much higher level, but you negotiate down to whatever is the common thing, right?
And to the point, we're capturing both, right? So as the client connects to something, this would be the properties, but these are negotiated in between stations to get what they're capable of. But Shami is correct. The maximum client capabilities is the maximum that the client is capable of. So we can see one of the things that it's interesting is like, what's the AX client adoption? How many clients are MU capable, right, when we're buying all of that nice fancy gear and all of that stuff? We know, we're prepared, we're doing analysis. And just as an interesting tidbit, right, everybody's talking about AX, everybody's talking about the adoption. I have run an analysis on the 19th of September on how many AX clients are across our entire population. And to understand that this is across millions and millions of the devices. Then I run the same just yesterday. There's 3 times more AX clients in about a 10-week span. Anybody? Yeah, in about 10-day span. That's that guy, right? See, we're contributing. And this is what we see. And where this comes into is providing an additional data sets to the ML. And by the way, this is how you can get to it. I can see every single device for every single property on my network from a top to down. If I have B clients, who are they? I want to use a mallet on them. Or what's the AX clients? I want to give the users high five. Right? The ability of big data, compute, and machine learning. One thing that we're doing is, this is not enough, right? We have more ambitious. We are doing the information on how the network is doing. This information is now. So for every single click that you're doing, we're asking the cloud to compute in real time all of the services, all of the scores, all of the everything. But we want to do more, right? So what is more is I'm going to show you. This is not live. This is in development. If it falls down, it's his fault, because he is not only leading the PLM, but also engineering. But what we're bringing is that calculation on a massive scale one step further. Instead of just doing that one calculation, we're doing the calculation on the health for every 10 minutes across every location that you have across the period of the time. So not only you'll be able to see my network's fine, but this one is red. There's something here. I can go directly in there with the click. And once you go in there, you would be able to see, okay, it's a device, right? And when you go into device, you would interact with the device and start learning and using, it's not working. His fault, engineering lead. And, oh, there it is. What's with the device, do the actions, and whatever. In just a couple of clicks, I can have thousands of locations, either as an MSP or a big organization, understanding I can drink my coffee in peace, and then go down and start troubleshooting on a device level or a connected client level or whatever, just because of the data and machine learning that we're doing.
So if you go back to the previous slide with the score, so one thing I would like to emphasize is actually a lot of logic that we put in is coming up with that score. Because when you compare yourself with about 5 or 6 APs, you can always say, I know what, your AP is doing good. When I have the ability to look across the whole globe, we can provide comparative analytics. For example, if you're a school with about 1,000 students, right? And you would like to know what your score 72 means, right? You know, how are the other schools across the globe with about a similar size, how are they doing? What is their average score? If they're also about 70, 75, it's very clear to you that, okay, you know what, we are operating in the same level. And so for us to be able to come up with those scores and for us to be able to very elegantly present that information that your network is doing fine, there is a lot of learning that's going on in the back, and the data that's necessary for all that learning is coming from our ability to process every frame and every byte. So even to get the max client, the thing that he just showed, every AP is processing all the frames, looking at each of the frame, collecting all that information and sending that to the cloud. So anything that's presented here, though it looks like a simple number, okay, it's an 83, but the logic and the amount of data that goes into figuring out what your health means, not only at a client level, not at a device level, but at a network level. And by anonymizing the data, we can actually show how your organization of size 500 is comparing against other organizations that are of a similar size for you to look at and go, you know what, why is my score 72 when most of the other organizations are getting like, let's say 85 or 90 or 100 score? What can we do? And the next step would be to use that learning to say, this is how you are operating your network, this is how you are connected, and other people are getting better scores because of this. So here is a suggestion. Maybe you have more clients per device than others are using. Maybe you are orchestrating and allocating your network with 40 to 50 clients per AP, but maybe 20, 25 is the right number because all the other companies of that similar size, here is the data. So this is essentially going to give you your Amazon experience where you go want to buy a bicycle and then it says, oh, by the way, other people bought this bicycle and here is their rating and this is their score. So it kind of gives you not only the ability to figure out where you are, but also to be able to compare. And by doing that naturally provides us the ability to suggest how you can move towards a better network by learning from everything that's happening in our whole network. So the key things are our ability to deploy. Not many people have the ability to deploy them in public cloud, in private cloud, and also on-prem. Our ability to scale, we can literally, the architecture allows us to scale, and our ability to process petabytes of data at each AP and able to collect all that across the whole globe and then bringing it together at our top level. So those are the ones I think mainly make this cloud very, very different from what we have seen and hopefully what you have seen across the vendor space here.
So are you actually comparing data like verticals, like different campuses, and how are you accounting for all the different use cases that even similar organizations would have? It seems like that score would be, I just don't know how that would be valuable to compare yourself without knowing the details behind all this.
So that's one perspective to look at it, compare it against, right, your peers, right? The second one is the second layer of the comparison, and I'll use the opportunity to steal the thunder of yet another alumni, Sam Clemens here, right? If I have location A and location B, is it good to upgrade from 20 megahertz to 40 megahertz? It depends, right, on the context.
Right.
Well, if one score increases and one score decreases, it does not depend. Yes for this site, not for that site. And this is how we're doing. So as we're capturing the relative scores, any change, whatever you are, as it increases, it's good. As it decreases, it's bad. And that's the second perspective to that comparison. Yeah.
And also, by the way, the scores are not fixed for your organization. We didn't go into all the details, but on the left side, we have the filtering. So you can actually now compare the scores across different, even in your organization, across different. So as you filter, the scores keep changing. It's not a static. See, this is the power of cloud. Since we have all the computation and everything is happening in the cloud, by picking up different locations, your scores will change appropriately, and you can see why they change. And the next step is for us to, even before you recognize, we can actually automatically tell you that, hey, out of the 6 locations you have, 3 of them seem to be doing fantastically well, but here are the 3 where the score is below. You may want to go look at it. And by the way, here is the suggestion as to what probably caused that score to be lower than your San Jose location is doing much better compared to, let's say, your Milpitas location or a North Carolina location.
Well, and I totally get comparing your locations where you have that context and you know what decisions you've made. But it sounded like you're saying we could compare it to other organizations outside our own.
Exactly. We have.
And that's the part that I don't understand how.
So we do have.
That would.
So one of the things that it's a part of machine learning is also supervised learning, right? Which is the input based on where it is, the state, how good are you affected with this? You open any app with, I don't know, losing weight, and you put on your parameters, and then you adjust it over time. Happens the same thing in here. Once you have the score that you're happy with, you set it as a baseline. So that's your input as a user. This works for me. That's an input for us to learning to adjust those based on over time. So over time, the algorithm gets better. The machine learning gets better. It gets more predictive. So we're kind of building persona based on the continuous feedback loop.
And typically in the past, people use baseline as their tribal knowledge. Hey, you know what? I've been Wi-Fi expert. I've been doing it. Okay, I think, negative 65 dBs. That's good RSSI, so that's my baseline. But our baselining is based on learning. So depending on your situation and what you think is right, over a period of time, we can actually adjust the baseline. For example, your WAN solution, right? If you're a small mom and pop store, your 1 gig WAN link probably is more than sufficient. But if you're a different company, you are expecting a different, behavior and different experience. So one of the things that the machine learning algorithm does is the baseline is relative to you, what you think is right, and then we measure it over a period of time, and your baseline adjusts accordingly to what should be good for you, not for others. And then you compare at that level, okay, where things are. So, any other questions?
Yep. So this is good. I mean, around, obviously the Hive product and where it all came from. How is this going to integrate then with Extreme APs, Extreme switches, the analytics? How is it all going to tie together? What's the plan?
Excellent. Do you want me to answer, or do you want to? Okay. So if you go back to my.
Come on. Oh.
So go back to the architecture thing. So. First and foremost,
barista.
So we are the way we architected is to answer your question. Yes, we are actually in the process of integrating those things. It is relatively very easy for us to do because of the architecture that we came up with. All we need to do is change a couple of our processing things and add just one more service that talks to the APs and the switches coming from Extreme. The rest of the stuff is exactly the same. We really don't need to do that much of different things for that. And that's not only true for the devices, but some of the services, right? I mean, they have a locationing service, in Extreme. Well, I shouldn't say
We have.
We are part of it. So, but we have, locationing services. We have the air defense, and we have, all the other cool features and services. All of them can be very easily integrated because we don't really need to touch anything. We don't need to stop the cloud. They're all running in parallel. You just create a new service, launch that service, connect it to the appropriate GUI, and off we go. So,
and I guess that's part of it is, at this point, as we all love to say so much, it's that single pane of glass, right?
Yep.
So we're all, everything is very separate, it seems like still. So that's kind of what the, because when we were here in February, I think we saw 2 or 3 products, and they were all their own little portal and all that. So it's just, when is getting it all together.
Slide with them all together.
So this is something that's really important to us, besides it being on the slide, is that Gregor can show you now that the AeroHive application that was known as Hive Manager, which you may have caught on that we're rebranding.
That was also my other thing was I still saw that up there. That's why that kind of prompted a lot of
Well, it has only been 6 weeks since we closed, right? So I know, I know.
Really?
Just keep that in mind, guys. If we were 2 public companies, we were not allowed to operate together.
Look, there's already been an AP die in 6 weeks, okay? We know you guys can move fast.
It has been. And so, but you can show them managing switches, yeah? Do you still have some in here? So just as an aside, I know that it wasn't a huge part of AeroHive's business for a long time, but there were switches in that portfolio, and there could be other switches in this platform. And without committing, from a roadmap perspective, since I'm, like I said, on the marketing side, but we already have plans to start adding in the Extreme switches.
Yep.
Shall we say safely by early next year?
Yes.
Well,
early next year. So.
Yeah, and I think that's just, is it, and I guess that's the question, is it the Hive Manager or Hive
ExtremeCloud IQ.
Okay.
Welcome to the future.
Yeah.
Yes.
Just because there's so many different ones, right? And they're all, the stuff we saw previously, it was all great. We really liked it. And it's just, is it all finally going to be in one place?
The answer is yes. And by early next year, you'll actually start seeing the heartbeat and the life of all them coming together in the public cloud. And then, of course, the features will be added as we go forward.
Right.
But you would definitely see it within a few months.
Okay.
Yeah. And that's what actually we're working on. And,
that's that cloud-driven end-to-end enterprise, all the way from the access points through to the data center with a single pane of glass view.
And then the key thing is, it's not that difficult for us to do because we can keep things parallel. We don't really need to go back and we have to add these new devices and nodes into the existing one. So that's the reason why we can literally develop in parallel and just attach the services as we go forward.
Okay.
So.
Cool.
And we're going to talk a little bit today about some of the security products and how the cloud can actually enable things other than just networking hardware. So I have been in charge of a product that we call A3. This is a network access control product. It's based on a 10-plus year open source NAC product that's got a lot of legs underneath it. But it was very difficult to use, hard to manage, hard to install, hard to implement. And we wanted to improve that, and we saw cloud as a way to really get there. So it's vendor agnostic, and I'm not actually here to talk too much about the NAC product. If you'd like to, we can talk a little bit later afterwards about it, but we'll talk a little bit about the architecture. So it does self-service onboarding, guest and BYOD management, device provisioning, profiling, of course, normal network access control, high availability clustering, and is all API driven. So it had a lot of the checkboxes that we really liked, but again, it was difficult to use, difficult to manage. So one of our first marching orders was to simplify it and to connect it to the cloud. So we could do this pretty easily. It's an OVA. You install this locally in your network, and then it reaches out and can go through the firewall and communicate with our cloud pretty easily on the outbound. But of course, when you then want to send instructions inbound, you hit the firewall and nothing can work. So it's very important to establish a way to do this. And of course, any automation that you want to do from the cloud via machine learning and other things was also blocked at the firewall. So what we did is we used a messaging technology called MQTT, which is typically used for Internet of Things communication. And we're using that as the messaging protocol to talk to the APIs locally. And then we wrap that inside of a TCP TLS connection. And so now we can actually publish and subscribe out to the cloud. We can have bidirectional secured communication within this tunnel. And in this way, we can automatically keep that session open and communicate down to the OVA anytime we want and make changes as appropriate. So I think you guys understand this. I've done like a really low-res graphic educational presentation. But yeah, so you set up a webhook, you can communicate outbound, we can start to feed things like monitoring information and what have you out to our cloud, and we can say, oh, the cluster is up, this many people are authenticated, it's behaving well, it's not behaving well. But the minute you want to make a change to that, of course, you're blocked. So we establish our communication to our 4th gen cloud, and then within an MQTT tunnel wrapped in a TLS WebSocket, we can then go ahead and communicate inbound with our communications. So this was the start. We want to start with this. So this is software driven now. And you get all the benefits that cloud brings you, right? You get the remote management, remote reporting, centralized access to all the large amounts of data. And of course, that's all elastic and expansive based on compute needs, networking needs, storage space needs, et cetera. But we can go beyond that. We can now take and service areas that NAC has never been able to service before. Imagine real estate offices or quick serve restaurants that are scattered in the thousands across various countries. You can't really put NAC in there because the latency and what have you would just make it too hard. But now you could put something very lightweight in those locations, manage them out of the cloud, and you've provided the ability to add NAC to places you couldn't before. In addition to that, you can add machine learning-based enhancements on top of this so that you can look at distributed security events, things like WannaCry virus. When it goes across all of Western Europe, you could actually see this in real time on the dashboard and be able to potentially take some action on that. And then in the future, we'll be able to do some really great things with a pure cloud-based onboarding solution where you wouldn't even need an OVA locally. As long as you had some extreme gear or anything that was set up with RadSec, you could actually onboard people without having to have the full-blown NAC solution on your local network. You store your radius and user store in the cloud, and everybody authenticates over that. So that's the solution that we've developed, and that is basically the end of my talk.
So on that model, so I know other folks that have them. So is this running in a public cloud, private cloud? How are you doing that?
So this could run in either. Right now it's running in our cloud. Okay. So this is the same architecture that Shyam was talking about earlier. Okay. And we can deploy in 20 minutes. It's very easy to set up, and the whole thing's ready to go.
I'm just thinking from, like an AWS standpoint, right? Because obviously lots of traffic flowing back and forth, and, costs start going up and that type of thing. That would be the only...
You are right, but for authentication kind of product, the traffic is not that much because you typically authenticate once or twice and maybe sometime in the middle. So regular traffic, that's a concern. But the benefit you get by having this in the cloud, way, is beneficial compared to the amount of extra traffic that you have to. And just to kind of iterate what he just mentioned, so this is also part of our cloud right now. It's working, and it's just one of the microservices we run in parallel, and we just add it. But the benefit of now having the ability to look at the authentication profiles of all the users across your organization throughout the globe is the power that you have the moment you have it there. So we can process that and use it for any AI-based suggestions as we go forward. One of them is the most common thing is the threats. You can detect the threats because you see them happening. If you're local in one place, you will not be able to see that, and you can start, hey, how come all the northeastern part of my organization is getting this threat? Something is going on there, right? So
and I guess that's what I'm just thinking more of, like, change of authentication, change of authorization, radius stuff, right? So as I'm roaming around, I'm going to different buildings, or, obviously from a wireless standpoint, I go wired, I go wireless, all that kind of stuff. I mean, that's a lot of data passing back and forth. Are you guys handling that on that side, or are you handling it elsewhere?
Actually, a lot of it can be handled on the AP itself when it happens, and some of the aggregated statistics and the metadata is the one that's pushed to the cloud. So it's somewhere in between, or not all the data always need to go to the cloud.
Yeah, your control plane and your data plane are still local, right?
Right.
Yeah.
I'm just thinking like radius specific. So I have a single SSID, and I'm doing, dynamic VLANing. So I connect, and based on radius attributes, that's where I'm going. So as I'm roaming around, if I'm doing, layer 3 roaming between multiple floors in a building because I've got tons of users, right? I've got buildings subnetted. So that's just a lot of changes.
That's handled true, especially with our access points. That's handled within the operating system of those as well. So that we already did that without a controller, without the cloud, just built into the operating system of the device previous to this. So if you're using, Extreme/Aerohive gear with that, it works well. And I just one other quick note before I hand it back to Sham. This is also showing how the partnership's really working. That as we get absorbed into Extreme, Extreme has NAC products. Right? And we're working right now to bring those all together and get them all managed out of the cloud. So you're going to see an extreme consolidation of those products. That was totally unintended. But yeah, consolidation of the NAC products under the same ExtremeCloud IQ management. So
I had a quick question. Why MQTT versus like gRPC? Was there a footprint issue with like sizing? Because normally I see MQTT for like
originally
point to point, like IoT to IoT, sort of
stateless, right? And it was just like quick.
This seems like a persistent streaming sort of thing. So gRPC.
That's what the WebSocket provides, is the persistency that we wanted.
Yeah, just
the messages are very small. The API calls are just really quick, and there was a secure methodology within QTTs to support this, using a messaging broker and what have you. But again, it didn't maintain state. So we just wrapped it in a WebSocket, encrypted with TLS, certificate-based encryption, and we're good. So I didn't make the decision on that. That was a previous engineering decision. But they had looked at quite a few things and decided on MQTT as the most economical. So
is there an on-prem option for the NAC as well?
Yeah, it is. Today, it's delivered as an OVA. The thing that we talked about, a pure cloud NAC, would be something that we're working on right now for the future.